Hi, welcome to my video on the type of discontinuity, and this video is about the jump discontinuity. Jump discontinuity is when the two-sided limits doesn't exist because the one-sided limits are equal. Let me explain using this example of the f of x. Again, when the two-sided limits doesn't exist because the one-sided limits are not equal. So we look at the f of x is square root of x minus 1 plus 3 when x is greater than or equal to 1, so that's on the right side. And negative x minus 2 when x is less than 1, and that's on the left side. So let's look at the limit of the f of x as x approaches 1. Let's approach 1 on the right side. So that limit as x approaches 1 on the right side is the square root of x minus 1 plus 3. So that becomes, we'll put a 1 in, the root of 1 minus 1 plus 3. So 1 minus 1 is 0, square root of 0 is 0, so that becomes a 3. So let's look at the limit of the f of x as x approaches, make that a name there, x approaches 1 on the left side. So that's the limit as x approaches 1 on the left side, so that becomes negative x minus 2. So we put a 1 in here, so the negative 1 minus 2, so that becomes negative 3. So we notice that the limit of the f of x as x approaches 1 on the right side, plus 1, is not equal to the limit of the f of x as x approaches 1 on the left side. That means that the limit of the f of x as x approaches 1, let me make that f of x there now, the limit, because the right side is not equal to the left side, that means it does not exist. So let's look at the graph of this one. So we look at, let's put that as 3, 1, 2, 3, 4 here. So this is the f of x, this is the x, and let's put these down. So that's a 4, and that's a negative 4, and there's a 4. And let's go with negative 4 here. So what we have, if we look at this one right here, which is the square root of x minus 1 plus 3, that right here, when it approaches 1, we get as x approaches 1 on the right side, we get a 3. So that's the point, 1, comma 3. Also, when x is 1, y is 3. So when you put 1 in here, you get a 3. So 1 gives me a 3. And notice this is equal to, so this point is right here. That's 1, 3. If you take, this is greater, so if we take a 2 and put a 2 in here, 2 minus 1 is 1. The square root of 1 is 1. 1 plus 3 is 4. So 3 gives us a 4. So we keep on going, and this is going to go like a half of a parabola going sideways like this. But notice that this point is equal to, so when x is 1, y is 3, so this point is solid. Now let's look at this one. When this point is, when x is 1, y is negative 3. When x is 1, y is negative 3 right here. But this point is not included because it's not equal to 1. But it's a line whose x-intercept is, the y-intercept is negative 2, right here. And the slope is negative 1, so it's down 1, right 1, or is up 1, left 1, up 1, left 1. So this is a line that's doing this, is a part of this line right here. So it's the left side of this line starting here. But notice this is a hollow dot. So notice that because of this graph, we can see that there's a jump. So the f of x is a jump. Discontinuity. Just take the time to spell that out. And again, it says the two-sided limit doesn't exist. So this is the two-sided limit. F of x as x approaches 1 doesn't exist because the one-sided limits right here are not equal. So that's one example. And let's continue. Let's continue with an absolute value. The h of x is the absolute value of x minus 2 over x minus 2. So just to recall, the absolute value of x is equal to x when x is greater than or equal to 0, equal to negative x when x is less than 0. So let's look at the limit of the h of x as x approaches 2 on the right side. So as it approaches 2 on the right side is like here greater than or equal to 0, so this is greater than or equal to 2, so that's the positive of x minus 2 over x minus 2. So that's the limit as x approaches 2 on the right side. That's a 1. So the limit, as we put in, that's a 1, so that limit is 1 because it's horizontal. So if we look at a graph of that, and here's the graph. So we just draw a little table here. This is the h of x. This is x. And so there we go. So that's a 4 and that's a 3. So as we approach 2 on the right side, as x approaches 2 on the right side, we get a 1. So as you approach 2 on the right side, we get a 1. So if you have 3, we have a 1. If you have 4, we have a 1. So this is it right here. So it's a horizontal line with a solid dot. Let's look at the limit of the h of x as x approaches 2 on the left side. So that's the limit as x approaches 2 on the, oh, I got a 1 there, on the left side, just a negative. I don't need negative 1, just a negative. Negative. So that's the negative of x minus 2. So it's on the left side, which is less than 0 here, so it's less than 2. So that gives us the limit as x approaches 2 on the negative side. They cancel and I get a negative 1. So that limit is negative 1. So right here, as x approaches 2 on the left side, we have a negative 1. But that point is not included because there's no equal to. So it's not equal to 2 here. So there it is, the horizontal line. So on the right, it's a horizontal line starting at x is 2 here and going right with a solid dot. Right here's a hollow dot going to the left. And as you can see, the limit of the h of x as x approaches 2 on the right side is not equal to the limit of the h of x as x approaches 2 on the left side. That means the limit of the h of x as x approaches 2 does not exist. It's defined at, well, 2 gives us a 0 over 0, so we have to use the rule to change this. Something like a removable, but it's not, you're not removing it. You're removing it in one sense, but this becomes a jump. So that means that the h of x is from this point here, which is 2, 1. So this point here is 2, comma 1. This point here is 2, comma negative 1. So there's a jump. So this is the jump discontinuity. So that's two examples of a jump discontinuity. Again, the limit on the left is not equal to the limit on the right, so the limit doesn't exist. So that's a jump discontinuity, and this, we already did two videos. One was the removable, this one is the jump, and we got one more to do. And again, in this video, if you like it, click the like button, click the subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, the content on my YouTube channel called Math Fully Explained, just one word. Thank you for viewing the video. Hope the video helped you. Bye-bye.